Okay, so to wake you up a bit after lunch, so here we have Tomislav, who will have a bit of a completely different presentation of how he solves his own problem on disk deduplication, right?
Disk deduplication,
so
yes.
Please.
Thank you, Martin. So, hi everyone. I'm going to talk to you today about, in a kind of proper engineering presentation about building tools to scratch your own itch. What I've done is I've built something called a heavy duty disk deduplicator. My name is Tomislav Nakić Alfirević. For just a little bit about me before I start. So I work at Infinity Technologies. I'm a solutions manager for satellite ground systems. During the day, during the night, I'm the president of the Cyclists Union, trying to get more people to get around town on bikes. And yeah, so the trigger for this talk is basically data backups, backup disks. So there are these, you can buy very large disks for basically nothing, and you get years of data piling up, or maybe even decades in my case, and it quickly becomes a mess. You get all kinds of copies all over the place. You don't know which copy you're looking at. Every 3 or 4 years, you kind of get to breathe a sigh of relief when you buy a new disk that's 4 times as big, and you're happy for about 6 months until everything fills up again. So there are basically these 2 or 3 problems with backup disks, where either you don't have enough space, or you have to manage multiple disks, or you don't know which version of a specific file you're looking at or using, and so on. So that was the problem that I set out with, and I'm not one to reinvent the wheel. So I took a look at what's available on the market, and there are few types of tools that have few areas of software that have so many tools available as disk deduplication tools, and one of the reasons is because there's no right way to do it. So, but there are wrong ways to do it, as you'll see. So I did a little investigation, and this is what I came up with. This is a list of all disk deduplication tools that I could find in a day. And I classified them according to all kinds of criteria. And so of these tools, I took a look. So these run on Linux, and of these work at the directory level as opposed to the file level, which I'll explain in a moment why it's important. And then these are the ones that aren't dead for many years now. So not a very good situation if you want to solve a problem. Not much to offer for large disks. So, and if you think it's like an operating system problem, I mean, I use Windows, for example, so I don't have this problem. It's mostly not. It's mostly, most of these tools are focused on files, and the problem with that, as opposed to directories, and the problem is that you get something like this. So you run the tool, and you get something like a few thousand duplicate files. In a more modern situation, you would get hundreds of thousands of duplicate files in these kinds of groups a quantity which you can't possibly handle manually, yet you can't really reliably tell the tool which copies to delete automatically. At least I don't think it's possible. So you have this problem of quantity that you can't really solve. And so what I started out with, what I started out with, these were my kind of constraints and requirements. I have a 4 terabyte drive. It's got nearly 7 million files and 700,000 directories. There are input-output performance constraints, which are quite strict. Capacity is cheap, but throughput is not. And of the kind of business requirements, I only want to get I want to get a very concise list of matches, which you can handle manually. So I want to show top-level matches, and I'll explain in a moment why that's important. So it turns out that this is not that easy a problem. When you start thinking about it, the naive approach would be to just list all the files and compare their content to every other file on the disk, and that would take about 180 centuries with this particular disk. So of just reading the content of the drive, and you might think that this is a naive approach, but when you look at descriptions of all these tools that do disk deduplication, that is exactly what they claim is necessary to get the job done. You can't trust file names, file sizes, hashes even. So they will plainly go out and say you can't trust MD5 for file content. It's 128 bits, so 10 to the power of 40 combinations of values, and you can't trust this. You have to read the content and compare it. This is, in my view, silly. So there is a less naive approach where you can read all the files on disk and then generate an MD5 hash for each file and then compare all the hashes of all the combinations of all files. And that's a little bit better. So you don't have to wait thousands of years, but it still takes over a day, or possibly multiple days, to read the entire content of such a disk, to just generate the hashes, to just read the data that's necessary to generate the hashes. And then you have to generate 7 million hashes and then make 7 times 7, around 40 billion comparisons of all these hashes. So there's a problem of scale here. It's not, you start with this idea, oh, it's simple to just find the matches, but the numbers work against you. So what I did was I came up with a couple of ideas to make the problem more manageable. First, I'm going to ignore file content. It simply takes way too much time. It's going to be too slow. It doesn't work. If I have two files that have the same name and the exact same byte size, the chances of these two files being actually different are very, very low, and it doesn't matter in the end because the tool doesn't delete them automatically. I can check if I want to, if these files are identical in the end. This is an important optimization. The second is I compare directories, not files. With a backup disk, I don't know. In my case, there are a lot of copies of directories, identical copies of directories, and I want to working at the directory level means you reduce the number of items by an order of magnitude. So 7 million files, but 700,000 directories. And when you have to multiply, you have to compare one item against the other. So you have 700,000 times 700,000 versus 7 million times 7 million. So you basically reduce work by 99%. You get 1% of the total number of comparisons. So this is a critical optimization. Then there's an option. It's not mandatory to ignore small directories. It has its shortcomings, but basically small directories will take a disproportionate number of all directories, and you're mostly not interested in them. You're interested in directories which are large, so that you can find the ones that are really taking up your space. That aside, I've implemented a program in Groovy, but it's not a completely clean Groovy solution. There is one line of shell code, of a shell command, which is this, and so this is all a prototype still, but it works. Anyway, what the line does is that it will for the disk that I ask, it will list all the directories recursively, the full path, and sort them according to, in a very particular way. Sort them according to the length of the string of the absolute path. And this is useful because as you go down this list, when you take a look at, when you're at a specific item, you know you have already processed all the subdirectories before because the subdirectories have a longer absolute path. So when you go down this list and check directory contents, you can be sure, because of the sorting, that you've already passed through, you have all the cached information about subdirectories already in memory. And so that's a kind of weird hack, but it works. And finally, there's an in-memory cache, so there's a pass through all the directories. It's basically a map of maps. So for each directory on the disk, the map has a list of files and directories inside with their associated sizes. And what the script will do is it will say these two directories are the same if they have the same files and they're of the same size. So those are some of the ideas that I decided on going with. What that turns into Groovy is 136 lines of code, which actually work. And what can I say? Groovy was handy because of clean, pure syntax, because of APIs which lend themselves nicely to scripting, because of first-class support for maps and collections. I'm not going to go into all the details, but lambdas obviously, and the Groovy shell, which is a nice interactive way of immediately checking if certain expressions you want to use work the way that you wanted them to work. So that's a kind of a scratch pad, and this could of course be done reasonably easy with Python or Ruby or Perl if you don't care to ever read that program again. But I did it with Groovy, and it's a Java conference, so there. And yeah, the process could be easier, could be nicer. With Groovy, I've also usually found it's difficult to, basically IDE support is still flaky at best. So debugging, refactoring, code navigation, things like that kind of work sometimes to a certain degree, kind of not. So it's not that. I mean, to anyone used to Java tools, it looks like a prototype of something, pre-alpha stage functionality. Yeah, so I did the work, and voila, this is the very nice output of the script. So there's a little progress indicator on top, and what it does is this is just an artificial test that I did with intentionally modified versions of the same directory to just see what it'll look like, and the output is very concise. It works reasonably fast. So when I have it run against my benchmark 4 terabyte disk, it takes about, I put it to work in the evening and it's done by the morning, close or something like that. And it's safe, it does no modification of disk content. It just lists, I've found these combinations of directories that have been duplicated. And I've compared how it works against a couple of other tools that work on Linux, and one of them has to go into file content, so it wouldn't work at all. With this disk, it would take forever. The other one crashed at 15% because it was way too much data for it. But when I ran them with a smaller, more artificial sample, they would produce an order of magnitude more output for you to have to manually inspect. So this is a duplicate of that, this is a duplicate, because what they operate at the file level. So they will tell you file A is equal to file B, whereas what I want to get is this directory is the same as this directory because all the files inside are the same. I need condensed information in order to be able to manually address them. And it's sorted so that you get the largest ones in first close up. So this works for me. This is exactly what I wanted to get. And then when you get this kind of output, you can start from the largest directories to the smaller ones and manually check which version you want to keep, which one you want to throw away, and so things like that. So, I'm sure that at this point you're all wondering, how could this possibly be any better? There are plans for version 0.0.2, which would include things like removing the magic one-liner, which is basically something that constrains it to Linux or BSD or things like that. So, I'll have to add 10 more lines of Groovy to make it basically platform independent and appeal to a wider audience. It would be interesting to be able to define a concept of similarity. Currently, the tool can identify identical directories and directories which are supersets of others. So this directory contains all the files in this one plus something else, and that it can do. But it would be useful to be able to find two directories which are nearly the same for a given definition of near. It would be nice to have some packaging so that it can be installed on at least on Linux in a single command. The GUI might come in handy to be able to more easily perform some kind of manual comparison of the results that the tool produced. Finally, this is a prototype, so it hasn't been optimized for speed yet, and so it does multiple passes through the file system the directory hierarchy. This could be improved further, so it could run 2 or 3 times probably faster, but for my purposes, this was good enough. It's available here on SourceForge. Yes, on SourceForge. I have a grudge with Atlassian and Git, and maybe one of these days I do a lecture on why Git is an abomination, but but not today. So this is in a Mercurial repository, and if you want to give it a try, if you want to take a look how it works, it's there. It's open source, so modify it to your heart's content. Let me know if you find it useful. And so that's more or less it. This is, if you want to get in touch, this is how you can do it. I'm about done here, so thank you for listening to me after for coming in such a in such a large number. I had expected Marin and myself to be the only ones here, and maybe a couple of crickets. So if you have any questions or comments, now is a good time, or afterwards in the halls. Thank you. Yeah.
This program basically doesn't solve synchronization issues.
Which?
For example, I have directory A that is on disk A, and directory A on disk B,
Mm-hmm.
and I put some files in disk B, and I compare it, and I see that the difference between A and B is this file.
Mm-hmm.
So it won't solve this problem to transfer file from this.
So it's not a synchronization tool. If you had 2 backup drives and you were interested in whether you have copies of files between these 2 that you didn't know about, then it could do that. It can work with any number of top-level folders. It could possibly be adapted to give you a very quick answer where you have some kind of desynchronization going on. So that it could do.
Because I'm using Total Commander.
Okay.
Windows.
Okay.
And I noticed the same options. So ignore file content, ignore
Mhm.
dates on file, white spaces, I think.
Yeah, well, what does it give you? It gives you a list of files or a list of directories?
On the right,
A list of files or directories?
files.
Exactly. So in my case, that would mean 100,000 matches. And what I really want is there are.
You can filter out only not, you filter out matches.
Mhm.
And you see only differences.
Yeah. But only difference is I have 7 million files on this disk. So
7 million differences.
no. So 7 million files altogether, and then of these, I would not be surprised if there are 200,000 or 700,000 copies. That would be 10% maybe, duplicates of some sort. So if you get 700,000 lines of duplicates, there is no way you can manually go through these before you die. So what I tried to do is I implemented something that basically says, okay, I found some kind of, these two files are the same. Are all these files in the same directory the same? Yes, okay, so this directory above is the same as this directory above. Are their parents the same? And I follow the directory tree upwards until I get the minimum amount of information where, okay, these two top-level nodes are the same and their parents are different. And that's what the information that I want. So that's the level at which I can be most effective when I manually inspect and see which ones I'm gonna delete or keep. Is that okay?
Disagree because in this program you have immediate control or how to say action available to do this stuff that you are needed to do. So you need some other program to do the work afterwards.
Absolutely. So it doesn't modify file contents. What I'm saying, I don't know. Maybe Total Commander is awesome and does all these things. I've gone through quite an extensive list of tools to do this, and I haven't found one that works the way I would think is optimal. It could be that there are others that I haven't detected, possibly one that's a general purpose file manager like Total Commander instead of a dedicated file deduplication tool. So it could be that there are hidden gems somewhere, but I'd need to see. I'm skeptical, having looked at about 30 different tools and none of them work the way that I would find most useful. I'm skeptical that this one would, but could be. There was a question in the back row somewhere. Yes? No. No, Git is like, I mean, very short. So what I think, so I've been using Mercurial for years before, so take this with a grain of salt. But so they can, it's like, I'm gonna say it in two ways. So Git would be a good framework to build a source control system on. So that's one. While Mercurial is a tool to manage your source. So that's one level, one way of putting it. Another way of putting it is like, if you're looking at, take a car for an example. So the user interface in a car is a steering wheel, some pedals, a shifter, or something like that, and that's what I would say Mercurial offers. What Git requires you to do is to individually move the valves up and down for the engine to keep running and things like that. And it does this in a way that it intentionally deceives you in the documentation about how to move the valves, and so it's horrible. But I have a long list of complaints that every time I'm serious. I'm gonna do a lecture. Every time I get tripped up by it, that's a way of venting. So I make a note. So this is a ridiculous way of doing things. I have to tell people about this. Anyway, so yeah, that's.
I was just wondering about these tests, which one?
You've seen the picture of the drive, so. So this is the hardware. Ah, sorry. So sorry. This is the other hardware. So it's a laptop. It doesn't really matter basically if you have any machine built within the last 5 years. Your bottleneck will be input-output. In particular, seek times. If you have to, I mean, you have 7 million files, of which you have to get a file size and file name. So lots of hard disk needles moving around, looking for the right position to read data from. Possibly, I don't know how the FAT is really implemented. It could be. It's not FAT. It's XFS. I don't know how it's internally organized, but it does take quite a lot of time. And even without the needle moving around in all these places, there is simply a very, very, very narrow pipe between the disk and the computer. I mean, it's up to 100 megabytes per second for large files. For small files, it can be as small as a couple of megabytes per second of transfer. And if you go into file content, so it doesn't really matter. I mean, what kind of a CPU or how much memory you have. It will be slow because of the disk. So that's another strategy. You can implement, go to all kinds of heuristic methods to your hardware content. So you could imagine taking 500 samples through a file as opposed to reading a 4 gigabyte file and making a hash of these precisely taken samples. In this way, drastically reduce the amount of data read from disk, and you would get more reliable results, of course, because you take into consideration file content, but at the risk of missing small differences in files. So obviously there's a trade-off. I don't know. I mean, the well thought through architecture of this solution supports this kind of extension. So as does comparing similar directories. So the exact algorithm how content is compared is arbitrary. So which is one of the reasons why there are so many of these tools. But all of them come with different performance and credibility trade-offs, and with very large drives like this, I don't think. So I think this approach works best. I don't know. I'm a bit partial here. Thank you very much.